These are 10 foods that can completely transform how everything else tastes, turning sweet into bitter, sour into sweet, and creating sensations your tongue never knew were possible. What you're about to discover will change how you understand the science of taste itself. Your sense of taste isn't just about enjoying food. It's an ancient survival mechanism that helped our ancestors distinguish between life-sustaining nutrients and deadly poisons. Sweet and salty flavors signaled foods rich in energy and essential minerals, while bitter and sour tastes warned of potentially toxic plants. But some foods contain compounds so powerful they can hijack this entire system, creating taste experiences that seem to defy logic. Let's start with perhaps the most extraordinary of these taste manipulators, the miracle berry. This small red fruit from West Africa contains a protein called miraculin that performs what can only be described as culinary magic. When you eat just one of these berries, lemons taste like candy, vinegar becomes sweet nectar, and the sourest foods transform into desserts. The science behind this transformation is fascinating. Miraculin is a glycoprotein consisting of 191 amino acids that binds to your sweet taste receptors. Under normal conditions, it just sits there doing nothing. But the moment acid touches your tongue, say from biting into a lemon, the acidic environment causes miraculin to change shape, suddenly activating your sweetness receptors. Your brain interprets this as an explosion of sweetness, even though there's no sugar present whatsoever. This effect was first documented in 1725 by French explorer Chevalier des Marchais, who observed West African natives chewing these miraculous berries before meals to make their food more palatable. The locals had discovered something that wouldn't be scientifically understood for another 250 years. The miracle berry's effects can last anywhere from 15 minutes to 2 hours, depending on your individual biology. In the 1970s, an American company called Miraculin tried to commercialize this natural sweetener, seeing its potential to revolutionize the food industry. But the FDA classified miraculin as a food additive, subjecting it to years of expensive testing. The company folded amid suspicions that the sugar industry had influenced this decision, and to this day, miracle berries remain largely a scientific curiosity rather than a commercial product. Today, these berries occasionally appear at exclusive flavor-tripping parties, where guests consume the fruit and then sample various sour foods, experiencing tastes that seem to violate the fundamental laws of flavor. Moving from sweet to savory, let's explore artichokes and their peculiar relationship with water. After eating artichoke, plain water suddenly tastes sweet, a phenomenon that affects about 60% of people due to genetic variations in taste perception. The compound responsible is cynarin, a derivative of chlorogenic acid found naturally in artichokes. Cynarin temporarily blocks your sweet taste receptors, essentially shutting them down from functioning normally. When you drink water afterward, the cynarin gets washed away, and your brain interprets the sudden return of normal receptor function as a rush of sweetness. This effect was first isolated and studied in 1959 by researchers at the Czechoslovak Academy of Sciences in Prague. The discovery helps explain why sommeliers struggle to pair wines with artichoke dishes. The cynarin interferes with the wine's intended flavor profile, making everything taste sweeter than it should. On the opposite end of the spectrum lies Gymnema sylvestre, known in Hindi as gurmar, literally meaning sugar destroyer. This climbing shrub from Asia has been used in traditional Ayurvedic medicine for centuries to treat diabetes. And modern science has revealed why it's so effective at curbing sugar cravings. The active compounds, called gymnemic acids, work by temporarily blocking your sugar receptors entirely. When you chew gymnema leaves or take a supplement containing these compounds, sweet foods suddenly taste like sand or cardboard. The effect typically lasts 30 to 60 minutes, during which time even the sweetest desserts become completely unpalatable. A typical therapeutic dose ranges from 200 to 800 milligrams per day, standardized to contain 25% gymnemic acids. Recent research in 2025 examined whether a 14-day gymnema intervention could reduce sweet food cravings in free-living adults, showing promising results for those trying to break sugar addiction. Perhaps no food creates a more dramatic sensory experience than Szechuan peppercorns. These aren't actually peppers at all, but the dried husks of the prickly ash tree. They contain a molecule called hydroxy-alpha sanshool that creates a sensation food historian Harold McGee describes as a strange, tingling, buzzing, numbing sensation that resembles the effect of carbonated drinks or a mild electric current. The first time you accidentally bite down on a whole Szechuan peppercorn is genuinely shocking. Initially, you feel nothing, so you keep chewing. Then suddenly, your entire mouth goes numb, as if you've been given dental anesthesia. The sensation has been measured to vibrate at about 50 Hz, the same frequency as a light electrical current. This numbing effect comes from hydroxy-alpha sanshool's interaction with specific neurons that are also targeted by modern anesthetics. Unlike capsaicin in hot peppers, which creates a burning sensation by activating heat receptors, Szechuan peppercorns work on entirely different neural pathways. The psychological impact is profound. Your pupils dilate, your heart rate increases, and everything you eat afterward tastes muted, compelling you to eat more to experience normal flavors. This is why Szechuan cuisine often combines these peppercorns with extremely spicy chilies. The numbing effect allows diners to consume higher levels of heat than would otherwise be tolerable. Interestingly, Szechuan peppercorns were banned from import to the United States from 1968 to 2005 because they could carry citrus canker, a bacterial disease. The ban was only lifted when importers agreed to heat-treat the peppercorns to kill potential pathogens. Fresh pineapple contains an enzyme called bromelain that literally begins digesting your mouth while you eat it. This proteolytic enzyme breaks down proteins by cutting amino acid chains, which is why pineapple makes such an excellent meat tenderizer. It's actually pre-digesting the muscle fibers. When you eat fresh pineapple, bromelain attacks the protein-rich cells lining your mouth and tongue, causing that characteristic burning, tingling sensation that can last for hours and significantly alter your taste perception. The enzyme was first isolated in 1891 by Venezuelan chemist Vicente Marcano, though its meat tenderizing properties had been known to indigenous peoples for centuries. Bromelain has found surprising applications beyond the kitchen. It's used in beer production to prevent cloudiness when beer is chilled, and some chemotherapy patients report that consuming pineapple helps reduce the metallic taste that's a common side effect of cancer treatment. The key point about bromelain is that cooking destroys it completely. Canned or cooked pineapple won't have any of these taste-altering effects because the enzymes are denatured by heat. Now, let's examine something most of us experience daily: the terrible taste of orange juice after brushing your teeth. This phenomenon is caused by sodium lauryl sulfate, a detergent commonly found in toothpaste that temporarily disrupts your taste buds. SLS works by breaking down the fatty compounds that make up parts of your taste receptors, particularly affecting your ability to perceive sweetness while simultaneously removing compounds that normally suppress bitterness. Orange juice contains both citric acid and added sugars, but after brushing your teeth, you can't taste the sweetness, only the bitter, acidic components. All research on this topic traces back to a landmark 1980 study published in Chemical Senses. The effects are temporary, lasting only minutes as your taste receptors recover from the physical disruption caused by SLS. Coffee's relationship with taste perception is surprisingly complex and somewhat controversial. Two major studies have reached seemingly opposite conclusions about caffeine's effects on sweetness perception. Cornell University research suggests that caffeine makes food taste less sweet, with researchers noting that when you drink caffeinated coffee, it will change how you perceive taste for however long that effect lasts. They found this effect occurred whether people drank regular or decaffeinated coffee, suggesting that other compounds beyond caffeine are involved. However, research from Aarhus University in Denmark found the opposite, that coffee makes people more sensitive to sweetness while reducing sensitivity to bitterness. Associate Professor Alexander Vike Fjellstad noted that when people were tested after drinking coffee, they became more sensitive to sweetness and less sensitive to bitterness. Recent 2025 research has identified new bitter compounds in roasted Arabica coffee, including mozambioside and its degradation products, which activate specific bitter taste receptors. Genetic predisposition also plays a role in how bitter these compounds taste to different individuals. Salt represents perhaps the most fundamental taste modifier in human cuisine. While we think of salt as simply adding saltiness, its real power lies in its ability to selectively suppress certain flavors while enhancing others. Various sodium-containing compounds reduce the bitterness of substances like quinine, caffeine, and magnesium sulfate. This selective suppression means that unpleasant tastes are more affected than pleasant ones, making the remaining flavors seem more intense by comparison. At low concentrations, salt reduces bitterness while increasing sweet, sour, and umami sensations, which is why a pinch of salt in chocolate chip cookies makes them taste sweeter, not saltier. The mechanism involves sodium ions interfering with bitter taste receptors while leaving other taste pathways largely unaffected. Higher concentrations of salt, above 500 millimolar, may actually be perceived as bitter or sour, while very low concentrations below 10 millimolar can taste sweet to some people. This explains why salt is considered a universal flavor enhancer. It's not just adding saltiness, it's fundamentally altering the balance of all other tastes. Baking soda creates a completely different type of taste modification through pH alteration. Sodium bicarbonate is alkaline with a pH around 8.3, and when added to recipes, it raises the overall pH level of the food. Higher pH levels tend to produce more bitter or soapy tastes, while lower pH levels create more acidic or sour sensations. In baking, this is usually balanced by combining baking soda with acidic ingredients like buttermilk, lemon juice, or brown sugar. When these react, they neutralize each other and produce carbon dioxide gas that makes baked goods rise. However, if baking soda is used without sufficient acid to neutralize it, the resulting alkaline environment creates an unmistakable, bitter, soapy taste that can ruin an entire dish. This is why recipes calling for baking soda always include acidic components. It's not just about chemical leavening, it's about maintaining proper pH balance for optimal taste. Finally, let's explore umami-rich foods and their complex interactions with other flavors. Umami, identified by Japanese scientist Kikunai Ikeda in 1908, represents our tongue's ability to detect glutamates and nucleotides, the savory, meaty taste that makes foods satisfying on a deep, almost primal level. Foods high in umami, aged cheeses, fermented products, grilled meats, mushrooms, don't just add their own flavor. They fundamentally change how we perceive other tastes, particularly in wine pairings. Umami-rich dishes can make wines taste more bitter and astringent than they would on their own, which is why sommeliers often choose older, more mellow wines for braised meats and rich stews. Cooking techniques can dramatically increase umami content. Long, slow simmering breaks down proteins into their component amino acids, concentrating glutamate levels. Oven roasting or drying concentrates these flavors even more. When foods containing glutamates are combined with foods rich in nucleotides, the umami effect increases exponentially. This is why combinations like aged cheese with mushrooms or tomatoes with anchovies create such deeply satisfying flavors. The discovery of umami created the foundation for the MSG industry, as Ikeda wanted to help poor farmers by creating a seasoning that would make simple rice and vegetable meals more satisfying and nutritious tasting. What makes these taste-modifying foods so fascinating is that they reveal how malleable our perception of flavor really is. We tend to think of taste as fixed and objective. A lemon is sour, sugar is sweet, salt is salty. But these foods demonstrate that taste is actually a complex neurochemical process that can be hacked, manipulated, and completely transformed. Each of these foods works through different mechanisms. Some bind to receptors, others block them. Still others alter the chemical environment of your mouth or change your brain's interpretation of neural signals. Together, they represent a kind of natural toolkit for flavor manipulation that has been discovered and rediscovered by cultures around the world throughout history. Understanding these mechanisms doesn't just satisfy scientific curiosity. It has practical applications for everything from helping diabetics reduce sugar cravings to assisting cancer patients who've lost their sense of taste. It's also driving innovation in molecular gastronomy, where chefs use these principles to create dishes that challenge diners' expectations and create entirely new taste experiences. The next time you experience the burning sensation from fresh pineapple, the numbing tingle of Szechuan peppercorns, or that terrible taste of orange juice after brushing your teeth, remember that you're witnessing millions of years of evolutionary biology being hijacked by clever chemistry. Your taste buds, designed to help you survive in the wild, are being tricked into experiencing sensations that nature never intended. These 10 foods remind us that in the world of taste and flavor, nothing is quite as simple as it seems.